Find the least common multiple of 5x to the third power and 4w to the second power. The least common multiple and the common denominator are synonymous. So the least common multiple, we're looking for the smallest number that both 5x cubed and 4x squared both go into. So in finding the least common multiple, we use every factor the most times it occurs in any of the factorizations. So when we break down each number, we have 5 times x to the third, and 4w squared is the same thing as 2 times w squared. Now again, we use every factor the most times that it occurs. So 5 occurs once, so we use 1 5. 2 occurs twice, so we use 2 2's. X to the third and w squared. So now we'll just multiply our coefficients together. 5 times 2 times 2 is 20, x to the third, w squared. So let's look at the next one. Here we have 7w to the 8th, y to the 5th, and 8w to the 7th, x squared, y to the 3rd. So when we look at the first, we have 7 times w to the 8th times y to the 5th. And 8 we can rewrite as 2 times 2 times 2. And then we have w to the 7th, x squared, and y to the 3rd. So remember, we use every factor the most times that it occurs for a single factorization. So we would use a 7. We would use 3 2's. Now both of them have w's. So the one with the highest exponent is w to the 8th. And they both have y's as well. And the one with the highest exponent is y to the 5th. And we still have the x squared, because remember, we use every factor the most time that it occurs. It doesn't have to be in both. So now we multiply. 7 times 2 times 2 times 2 is 56. W to the 8th, y to the 5th, and x squared. The next problem, again, we're finding the least common denominator or least common multiple of 3 over x and 2 over 4x plus 1. So I'm going to put the 4x plus 1 in parentheses. And we don't look at the numerators at all because we're looking for the least common denominator. So the numerator, again, are not important at this point. Once we get into adding and subtracting, we'll do more with that. But our denominator in its factored form for the first is x, and in the second it's 4x plus 1. Remember, we use every factor, so we use the x and we use the 4x plus 1. You can leave it in its factored form. So the next problem, we're finding the least common denominator of 8 over x squared plus 7x plus 10 and negative 2 over x squared plus 5x. Again, just dealing with the denominator. So I put anything that has plus or minus signs or are polynomials in parentheses. and factor whenever possible. So x squared plus 7x plus 10, I can use my shortcut of factoring since my leading coefficient is 1. And the factors of 10 that add to a positive 7 are positive 2 and positive 5. Order does not make a difference. Now in my second, I have x squared plus 5x, so I'm going to remove the greatest common factor, which is x. And when I do that, that gives me x times the quantity x plus 5. So remember, I use every factor. So I use the x plus 2. They both have x plus 5, and they both only occur once. So the most times that it occurs is only one time per factorization. So I'll only use one x plus 5. And I still have a factor of x. I'm going to just put it up front. It's a better practice to do that. It doesn't make it wrong if you put it in between or at the end. So our least common denominator is x times the quantity x plus 2 times the quantity x plus 5. Now, what we're heading to is adding and subtracting fractions, so we need to get a common denominator. So we have 3 over 4 y to the 8th equals, and we have a blank in the numerator, and our denominator is 24 y to the 9th. So I'm just going to rewrite that, giving myself a little bit of space. So what I'm going to determine is, what did I multiply 4y to the 8th times to give me 24y to the 9th? So I can divide. So 24 divided by 4 is 6. And remember, when you divide variables, you subtract. So 9 minus 8 is 1. So I multiplied 4y to the 8th times 6y to the 1st to give me 24y to the 9th. Now what I do to the denominator, I have to do the exact same thing to the numerator. And it doesn't change the value because anything over itself, 6y to the 1st over 6y to the 1st is 1. So I'm essentially multiplying by 1. So now I multiply 3 times 6y, and that gives me 18y. So my final answer would be 18y over 24y to the 9th. The next problem. I have 6 over y plus 5, and that equals blank over y plus 2 times y plus 5. So we do the same thing. How did we get from the y plus 5 in the denominator to y plus 2 times y plus 5? Very obvious, we multiplied by y plus 2. Now again, we can't just arbitrarily put that there. Whatever we do to the denominator, we're going to do to the numerator as well. And so now in the numerator, I am going to distribute, because we're going to need to do that when we add and subtract. So this gives me 6 times y, which is 6y, and 6 times 2, which is 12. So our final answer would be 6y plus 12 over the quantity y plus 2 times y plus 5. And again, order doesn't make a difference as far as your factors are concerned. Now let's talk about some simple addition problems, and then we'll use this concept we just talked about to do more. So remember, when we're adding fractions, we need a common denominator. And in this case, we have a common denominator of 5b. So we're adding 6 over 5b to 8 over 5b. Since we have a common denominator, the denominator doesn't change, nor do we have to make a change to any of the fractions. And we simply add the like terms in the numerator. 6 plus 8 is 14. Now, if we could reduce, we would, but we can't. So our final answer would be 14 over 5b. Next one. Here we have 4c minus 5 over 6c plus 5c plus 2 over 6c, and the directions again are to add. Well, we have our common denominator already as 6c, so that doesn't change. So now we're going to combine like terms in the numerator. 4c plus 5c is 9c, and negative 5 plus 2 is negative 3. So we simplify if possible. So the only way we can simplify is if something divides into the 9, the 3, and the 6. And 3 divides into all three, so I divide it out. So 9 divided by 3 is 3. 3 divided by 3 is 1. And 6 divided by 3 is 2. So our final answer simplified would be 3c minus 1 over 2c. Now keep in mind, and I'm going to show you by putting this in parentheses, that 3c minus 1 cannot be simplified in parts. 3c minus 1 represents a factor. So I couldn't simplify by dividing these c's out. So our final answer again, 3c minus 1 over 2c. Now, in some cases, we're going to need to factor. And so we're going to factor the denominators. They are the same, so we don't have to factor them initially, but we may need to factor them at the end to reduce. So we'll do that first. So both denominators are z squared plus 6c plus 8. So we have z over z squared plus 6z plus 8 plus 4 over z squared plus 6z plus 8. So I'm going to factor. And again, we can use the shortcut because our leading coefficient is 1. So that'd be z times z. And then we're looking for the factors of positive 8 that add to a 6, which would be 4 and 2. So we're adding z over z plus 4, z plus 2, plus 4 over z plus 4, and z plus 2. Now, since our denominators are the same, we can go ahead and add our numerator. I'm just rewriting the denominator, z plus 4 and z plus 2. And since there aren't really like terms to combine, our numerator z plus 4 would give us just z plus 4. And again, I'm going to put those in parentheses. So our last step is going to be to reduce. So they both have factors of z plus 4, so they reduce to 1. And in our numerator, we have 1. And in the denominator, we have z plus 2. So our final answer would be 1 over z plus 2. Our next problem, we don't have common denominators, and we also have a subtraction problem. So what I do is I change all subtraction problems to adding the opposite. So that means I change it from 7 over 4 minus 3 over 5b to 7 over 4 plus negative 3 over 5b. So I would change all the signs in the numerator or the denominator. So I always choose the numerator for now. Okay, so remember, whenever we're adding fractions, we have to have a common denominator. So we're finding that least common multiple or that common denominator. So our one denominator is 4, which is really 2 times 2. And our second denominator is 5b, which is 5 times b. So remember, we use every factor. So we use 2 times 2 and 5 and b as well. So when we multiply that together, 2 times 2 times 5 times b, that gives us 20b. So that's our common denominator. So I set up the problem vertically. So I have 7 over 4, and I'm adding to it negative 3 over 5b. Now before I can do that, I need to establish my common denominator, which we said is 20b. So now we're going back to a problem we have done previously, and we ask ourselves, what did we multiply 4 times to give us 20b? So again, I could divide 20 by 4, and that would give me 5, and I need to account for that b. So I multiplied 4 times 5b to give me 20b. So what I do to the denominator, I do to the numerator as well. So 7 times 5b is 35b. Now let's go to the second one. I have negative 3 over 5b, and my common denominator is 20b. So I divide 20 by 5, and that gives me 4. And I already had the b, so I didn't multiply by any b's. So all I multiplied is by 4. So I multiply my numerator by 4 as well. So negative 3 times 4 gives me negative 12. Now I'm going to combine these. So there's nothing like, so I'm just going to combine them and express them as two separate terms. 35b minus 12, and remember your denominator stays the same. Now, nothing goes into 35, 12, and 20, so that's my final answer. Remember, in order to reduce, something has to divide into all the terms, not just 2 of the 3, but all of them. The next problem. We have 7a plus 2 over 4a plus 2a minus 5 over 8a. So since we're adding fractions together, we need a common denominator. So if I look at 4a, that can be rewritten as 2 times 2 times a. And 8a can be rewritten as 2 times 2 times 2 times a. So remember, in finding the common denominator, we use every factor the most times that it occurs. So both of them have 2's, but 8 has 3 2's, so we include all 3. So we've taken care of the factor of 2. Now they both have a's, and the most time it occurs in a single factor is once. So our common denominator is 2 times 2 times 2 times a, which is 8a. So again, I'm going to set up the problem vertically, and I'm going to use my parentheses. So I'll have 7a plus 2 over 4a and 2a minus 5 over 8a. Now remember, we established our common denominator to be 8a, so we need to make whatever change to both the numerator and denominator. So in the first one, if I divide 8 by 4, I get 2, and they both have just a to the first, so I didn't need to multiply by a. So now I need to multiply 2 times the 7a and the 2, so I'm going to distribute the 2 times each one. So 2 times 7a is 14a, and 2 times 2 is 4. Now for the second, since the denominator is already 8a, I really didn't need to make a change. So the 2a minus 5 over 8a remains unchanged. Now I combine like terms, keeping in mind my denominator is going to remain 8a. So I have 14a plus 2a, which is 16a, and 4 plus negative 5 is negative 1. So I have 16a minus 1 over 8a. Remember, nothing goes into all three, so that would be my final answer. 16a minus 1 over 8a. And some people ask, do I need the parentheses? You don't, but if you want to put them there, it won't mark it wrong. Let's do another addition problem. We have 3 over x plus 4 over x plus 5, and I'm going to put the x plus 5 in parentheses. So again, when I look at finding a common denominator, the first denominator has factors of just x, and the second one has factors of only x plus 5. So in finding our common denominator, remember, we use all factors the most times that it occurs in a single factorization. So we use both x and x plus 5. That's our common denominator. So I'm going to rewrite my problem vertically. So I have 3 over x and 4 over x plus 5. And remember, we established our common denominator as x times x plus 5. So now I'm going to compare and multiply by the missing factor or factors. So 3 over x, and our common denominator is x times x plus 5, so I'm missing the factor of x plus 5. So I apply it to both the numerator and denominator. And now I distribute the 3 times the x plus 5 in the numerator. So that gives me 3x plus 15 over x times x plus 5. Now for the second one, I have a denominator of x plus 5, and my common denominator is x times x plus 5, so I'm missing that factor of x. So I multiply numerator and denominator by that missing factor. So 4 times x is 4x. And now I combine like terms, and remember, my denominator remains the same, x times x plus 5. And combining like terms, 3x plus 4x is 7x, and 15 can't be added to anything, so it remains 15. So there are no common factors to reduce, so my final answer would be 7x plus 15 over x times x plus 5. Let's look at another one. Here we're adding two fractions together, x plus 3 over x minus 3 plus x plus 8 over x minus 7, and I'm putting them all in parentheses. So when I look at my two denominators, the first denominator is just x minus 3, and the second denominator is just x minus 7. So remember, in establishing a common denominator, we use all factors the most times that it occurs in a single factorization. So our common denominator is x minus 3 times x minus 7. So I'm going to rewrite my problem vertically because it's just easier for me to work. So I have x plus 3 over x minus 3 plus x plus 8 over x minus 7. So we've established our common denominator, so we rewrite it to the right of the equal sign. So our common denominator is x minus 3 times x minus 7. Now we find out what factor is missing, if any. So the first denominator is x minus 3, and our common denominator is x minus 3 times x minus 7. So we're missing the factor of x minus 7. So we multiply that times the numerator and denominator. Now we're going to use the distributive property, or the FOIL method, to multiply the x plus 3 times the x minus 7 in the numerator. So x times x is x squared. X times negative 7 is negative 7x. Positive 3 times x is positive 3x. And positive 3 times negative 7 is negative 21. Now I'm not going to combine like terms here. I'll do that when I combine the numerators. So in my second, I have a denominator of x minus 7, but I'm missing that factor of x minus 3. So I multiply numerator and denominator times the missing factor x minus 3. So again, we're going to use the distributive property to multiply x plus 8 times x minus 3. So x times x is x squared. X times negative 3 is negative 3x. Positive 8 times x is positive 8x. And positive 8 times negative 3 is negative 24. So now we're going to combine like terms. And remember, in our final answer, our denominator remains the same, which is x minus 3 times x minus 7. So let's combine like terms, starting with the x squareds. So the first one has 1x squared, as does the second. So 1x squared plus 1x squared gives me 2x squareds. Now I have 4 terms that have x. So I'm going to combine them all at once. So I have negative 7x plus 3x, which is negative 4x, minus 3x is negative 7x, plus 8x gives me positive 1x. So negative 7x plus 3x is negative 4x, minus 3x is negative 7x, plus 8x gives me positive 1x. So now I go to my two constants. Negative 21 plus negative 24 gives me negative 45. So my final answer is 2x squared plus 1x. You don't really need that 1 in front, but 2x squared plus 1x minus 45 all over the quantity x minus 3 times the quantity x minus 7. Let's look at one more problem, a subtraction problem. And we have 4 over x plus 4 minus 3 over 5x plus 20. And remember, we're going to change subtraction to adding the opposite. So now we're going to be adding negative 3 over 5x plus 20. So keep in mind again, let's look at the factors. The first denominator is x plus 4. The second denominator is 5x plus 20, but we can factor out a 5. And so that gives us 5 times x plus 4. So when we look at finding our common denominator, remember we use every factor, so we're going to use the 5. And they both have x plus 4 to the first power, so we only use x plus 4 one time. So our common denominator is 5 times x plus 4. So I'm going to rewrite my problem vertically. So I have 4 over x plus 4 plus negative 3 over, I'm going to write it in its factored form, 5 times x plus 4. Now, to the right of the equal sign, I'm going to write the fraction with just the denominator we established, which is 5 times the quantity x plus 4 for both. And now we compare to find out what factor was missing. So for the first one, our original denominator was x plus 4, but our common denominator is 5 times x plus 4, so it was missing the factor of 5. So I multiply numerator and denominator times 5. So 4 times 5 is 20. In our denominator, of course, 5 times x plus 4 gives us our common denominator, 5 times the quantity x plus 4. Now for the second one, we have negative 3 over 5 times x plus 4, and 5 times x plus 4 is our common denominator, so we don't need to make a change. So it remains negative 3 over 5 times x plus 4. Now we combine like terms. So we have 20 plus negative 3, which is 17, and that's over our common denominator, 5 times the quantity x plus 4. So that would be our final answer.